Warm greetings to everyone. This is Sweatcha from JNTU College of Engineering. Today I'm going to detail it about a new nuclear material known as alloy 617. Alloy 617 is a solid solution strengthened nickel chromium cobalt molybdenum alloy with an exceptional combination of high temperature strength and oxidation resistance. The alloy also has excellent resistance to a wide range of corrosive environments, and it is readily formed and welded by conventional techniques. It also has traces of aluminium, carbon, iron, manganese, silicon, sulfur, titanium, copper, and boron. The limiting chemical combination of alloy 617 make the alloy resistant to a variety of both reducing and oxidizing media. The aluminium in conjunction with chromium provides oxidation resistance at high temperatures. Solid solution strengthening is imparted by the cobalt and molybdenum. The combination of high strength and oxidation resistance at temperature over 980 degrees centigrade make this alloy an attractive material for such components as ductile combustion cans and transition liners in both aircrafts and land-based gas turbines. The chemical composition of this alloy is shown in table 1. Now let us see the physical constants and thermal properties of this. Melting range and some physical constants at room temperature are shown in table 2. The alloy's low density compared with tungsten containing alloys of similar strength is significant in applications such as aircraft gas turbines where high strength to weight ratio is desirable. Thermal properties of alloy 617 at temperatures 21095 degrees centigrade are given in table 3. Values for thermal conductivity and specific heat are calculated, and other values were measured. Thermal expansion of this alloy is lower than that of most other austenitic alloys, reducing stresses from differential expansion when the alloy is coupled with carbon steels or low alloy steels. Alloy 617 has high mechanical properties over a broad range of temperatures. One of the alloy's outstanding characteristics is the strength level it maintains at elevated temperatures. The resistance of the alloy to high temperature corrosion enhances the usefulness of its strength. High temperature tensile properties of solution annealed cold rolled sheet are presented in figure 2. The tests were performed in the transverse direction on sheet of 0.187 inches thickness. And figure 2 and figure 3 shows us the high cycle fatigue strength and low cycle fatigue strength of this alloy. Alloy 617 exhibits good metallurgical stability for an alloy of its strength level. And then coming to the creep and rupture properties, it displays exceptionally high levels of creep and rupture strength even at temperatures of 980 degrees centigrade and above. That characteristic combined with good resistance to oxidizing and carburizing atmospheres makes the alloy especially suitable for long-term high-stress use at elevated temperatures. And the given figures, figure 7 and figure 8 shows the creep and rupture properties of this material. Composition of alloy 617 includes substantial amounts of nickel, chromium and aluminium for a high degree of resistance to oxidation and carburization at high temperatures. Those elements along with the molybdenum content also enable the alloy to withstand many wet corrosive environments. While alloy 617 exhibits excellent resistance to aqueous corrosion by many media, the alloy is normally only used at high temperatures. This alloy has good fabricability. Forming, machining and welding are carried out by standard procedures for nickel alloys. This alloy has good hot formability, but it requires relatively high forces because of its inherent strength at elevated temperatures. In general, the hot forming characteristics of alloy 617 are similar to those of alloy 625. The temperature range for heavy forming or forging is 1010 to 1205 degrees centigrade. Light working can be done at temperatures down to 925 degrees centigrade. Alloy 617 is readily cold formed by conventional procedures, although its work hardening rate is high. Alloy 617 is normally used in the solution annealed condition. That condition provides a coarse grain structure for the best creep rupture strength. It also provides the best bend ductility at room temperature. Solution annealing is performed at a temperature of 1175 degrees centigrade for a time commensurate with section size. Cooling should be by water quenching or rapid air cooling. Now let's see the importance of this alloy as a new nuclear material. Alloy 617 is a commercial alloy which is qualified for its new use as a nuclear material, expanding the base of nuclear operating temperature. It is one of those rare valuable materials which got a place in NLC's code. A combination of nickel, chromium, cobalt and molybdenum, this alloy can be used in tomorrow's advanced nuclear plants because it allows high temperature operation. In contrast to light water reactors that operate around 290 degrees centigrade, this alloy will run up to 2 or more times hotter. This newly qualified material can be used in design and construction up to 950 degrees centigrade, resulting in enabling new higher temperature concepts. Now let's have a look at the other applications. The combination of high strength and oxidation resistance at temperatures over 980 degrees centigrade makes this alloy an attractive material for such components as ducting, combustion cans, and transition liners in both aircraft and land-based gas turbines. Because of its resistance to high temperature corrosion, the alloy is used for catalyst grid supporters in the production of nitric acid, for heat treating baskets, and for reduction boards in refining of molybdenum. Alloy 617 also offers attractive properties for components of power generating plants, both fossil fueled and nuclear. So in general, it can be used as combustion cans and ducting for gas turbines, transition liners for gas turbines, casing for industrial gas turbines, industrial furnace components, and nitric acid catalyst grids. To conclude, we can say that in addition to high temperature applications in the aerospace and power generation markets, the alloy is also used in high temperature petrochemical plants for applications such as nitric acid catalyst grids, where metallurgical stability is critical.